so 113, we're going to look at different multiple representations of functions, and we'll talk about what that even means later. What does it mean to create multiple representations of a function? So the multiple representations should be obvious, right? We're going to have a graph, we're going to have a table, maybe pictures of it. But what actually is a function? That's what we'll talk about more later. Anyway, in the previous lesson, you observed graphs of linear, inverse variation, and exponential functions. In this lesson, you will investigate multiple representations of various functions, describe their patterns of growth, and describe characteristics of the graph. So it's asking us to open this resource page, which we will. We're going to look at the pattern. We're going to complete figure 4. We're going to complete the table, graph, and equation. Then we're going to sort of describe what the graph looks like. So I'm going to close this here, and this is ultimately what I need to write, but again, I need to be in the software so that I can actually write on it. So it should be this one. Okay, so as I look at this one, I can see figure 0 has 3 tiles. I'm stuck on that. Okay, so figure 0 has 3 tiles, figure 1 has 8, 2 has 4, 6, 8, 10, 13. Figure 3, I'm guessing will have 18, but let's confirm that. So 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18. So it looks like we're adding by 3 each time. So I would expect this to be 23 and this to be 28. What would figure 4 look like? Well, it looks like it starts with just these 3. And then it goes to 4, and then to 5, and then to 6. So I'm guessing I'm going to have 7 in the middle. 1, 2, 3, 4, 5, 6, 7. Right? I'll have 7 in the middle. And then it has 0 by 2, 1 by 2, 2 by 2, 3 by 2. So I'm guessing it'll go 4 by 2 here. So I'm going to go up 4. So something like that. And then same thing on the bottom. And if I were to graph this 0, 3, 1, 2, 3 would be there, 1, 8 would be there, 2, 13. I might have missed by 1, I apologize. I'm not going too crazy trying to make sure I hit it exactly by 1, but we would get that in line. And again, some of these points might be off by a point or so. I apologize if they are. Okay. Figure 2 is a little bit tricky. So first of all, we were supposed to write the equation. We didn't write the equation. So it looks like it's y equals 5x plus 3, right? I know that because the growth is 5 and the starting point is 3. So we're going to go into the equations of lines more in chapter 2. So if you're not quite sure, the slope is what we start with, and then the 0 point is the y-intercept. Okay, so here they actually give us the equation. And we are able to sort of figure out here that if I plug 0 into this equation, I'm going to get 4, right? 0 squared plus 4. So interestingly enough, I have 4 here. A lot of times kids think it's like 1 or 0 or something like that, but these 4 in the middle stay, right? And then there's 0 in the middle, then they go out, and there's 1 in the middle, then they go out, and there's 4 in the middle, then they go out, and there's 9 in the middle, so it grows by squares, 0 squared, 1 squared, 2 squared, 3 squared. That's what that's going to look like. But anyways, figure 1 has 5, figure 2 has 8, figure 3 has 9, 10, 11, 12, 13. Again, we could just go over here. 3 squared is 9 plus 4 is 13, which I will do for this one. This is going to be 16 plus 4 is 20. So again, we're going to have that 4 by 4 in the middle. And then we'll just have the 4 corner pieces. And that is what our 4th figure will look like. And our 5th figure will be 25 plus 4 is 29. And now we will graph this, 0, 4. And again, I probably will not be perfectly precise on this. But one thing is for sure, we definitely are not coming up with a line right here. We seem to be getting a little bit of a curve on this. So it's beginning to curve upwards. All right, on tile pattern 3, again, they give us the equation here. So we know that this figure 1 looks like, figure 0 looks like, which has 1, 2, 3, 4. We know that 1 has 1, 2, 3, 4, 5, 6, 7, 8. Pattern 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And it looks like we're doubling each time. So my suspicion is there's going to be 32 right here, right? If I plug 3 in, 2 to the third power, 2 times 2 is 4, times 2 is 8, 8 times 4 is 32. Don't forget order of operations say we have to do the exponents before we multiply. So this would be 2 to the fourth power, which is 16, times 4, which is 64. And this would be 2 to the fifth power, which is 32, times 4, which would be 128. So this is what my table is going to look like. Now I need to figure out my graph. I've been ignoring that. So I start with 3 and I go 1. It looks like I'm adding 1 diagonally each time, and then a row of 3 each time doubles. So I would have 8 rows of 3 here, it looks like. So 1, 2, 3, 4, 5, 6, 7, 8. That looks like I just barely fit that in. And then I would have, so 1, 2, 4. Oh, I guess maybe I'm going to have 8 here, right? So I already have 24. Yeah, I'm going to have 8 here so I can get to 32. So 1, 2, 3, 4, 5, 6, 7, 8. You like my squares? They look amazing. I probably should have put this up one. But again, so this doubles as well. 1 to 2 to 4 to 8. And then this goes 1 row of 3 to 2 rows of 3s to 4 rows of 3s to 8 rows of 3s. So I'll graph this 0, 4. And again, I'm sure you'll be able to call me out that I will probably miss some, which is fine. But you can see 64 is going to be, I don't know, maybe somewhere up there. So we have another distinct curve here. A little bit steeper than that one. And then finally, we have this equation. Now, this is going to be interesting. It says figure 0 is undefined. You're not allowed to divide by 0. We actually kind of talked about that. 0 over 48 equals 0. 48 over 0, 0 doesn't go into 48 ever, so it's undefined. But 48 goes into 0 0 times. So anyway, so there is no, that's not a 0. That's like saying you can't have anything there. But figure 1, 48 divided by 1 is 48. So there's 48 dots here, or squares. Here, 48 divided by 2 is going to be 24. Divided by 3 is going to be 16. So figure 4, I guess, is going to be 12. 48 divided by 4 is 12. But you can see the way they're doing it is 1, 2, 3, 4, 5, 6, 7, 8. And then they're going halves. 9, 10, 11, 12. So kind of interesting the way they do that for us. We divide by 5, we get 9.6. So again, there is nothing at 0, 0. We're not going to put anything. 148 is going to be here. 224 is going to be here. 316. 412. 5, 9.6. So it looks like we have an inverse relationship here. As x goes up, the y goes down. As x goes down, the y goes up. There is no intercepts on this one. Here, we definitely have an intercept, but it's curving upwards. Looking like we definitely have some exponential growth on this one. Here, it's a quadratic. We don't see the negative, but it would actually go like this to the negative. It sort of makes a bowl. That's going to be a shape you learn in Integrated 2. We won't do much with that this year at all. And then this one is just linear growth. We have our intercept, and we would have another intercept if it was allowed to go negative. So that is 113 in a nutshell.